Not all IP addresses are created equal, and we're going to see in the next couple of videos that we have different classes of IP addresses. We've got Class A, Class B, Class C, Class D, Class E, and we're going to see how to tell the difference. The number in the first octet, that's our clue as to what class of IP address we're dealing with. We also have publicly routable IP addresses that can be routed through the public internet, and we're going to have private IP addresses meant for internal use only within our network. Let's get started though by taking a look at these 5 different classes of IP addresses.
Now understand that when we take a look at an IP address, we really don't know which of those 32 bits represent the network and which of those 32 bits represent the host unless we've got a critical piece of information. Do you remember what that critical piece of information was? It's the subnet mask. The subnet mask draws that dividing line saying these are the network bits and these are the host bits. How do we know what that subnet mask is? We're going to see that we can set that dividing line ourselves, but there are defaults, and those defaults are different for some of our different classes of addresses. So let's talk about these 5 different IPv4 address classes: A, B, C, D, and E. And please understand that classes A, B, and C, they're the only classes of IPv4 addresses that are going to be assigned to a host. Address class D, that's used for something that we'll be discussing called multicast, but we send to a destination multicast address. No computer, no host is ever going to be assigned this range. It's a destination-only address, and as a result, you see it doesn't even have a default subnet mask. And I've been doing networking for many, many years now, and I've always heard that a Class E address is used for experimental purposes. Well, I've never seen such an experiment. I've never seen Class E used anywhere, and you probably won't either, especially with the advent of IPv6. But that's what you'll probably read in the literature, that it's used for experimental purposes. And you can see in this table that we've got a classful mask, written as dotted decimal and written in prefix notation, but we've got a classful mask for classes A, B, and C. This classful mask, that's the default subnet mask for addresses in that class. For example, if we had an IP address of 10.1.2.3 and I told you that we were using the classful mask, that would tell you that the first 8 bits represented the network and the remaining 24 bits represented the host. And again, we're going to be able to adjust that default, but it's important to memorize. You should memorize the default or the classful subnet masks for these 3 different classes of addresses. And you can determine the class of address simply by looking at the first octet. If the value in that first octet is in the range of 1 through 126, it's Class A. If it's in the range of 128 through 191, it's Class B. If it's in the range of 192 through 223, it's a Class C address. And here is a very common point of confusion. Many people think that if we change the default subnet mask, which we can do, we could say, no, that 10.1.2.3 address, instead of having 8 bits, it's got 24 bits. Many people look at that and say, oh, well, now it's a Class C address. That's not true. Big point here. The class of IP address is entirely dependent on that first octet. It doesn't matter what the subnet mask is. It doesn't matter what we have in octets 2, 3, and 4. It's entirely determined by the first octet, regardless of subnet mask length. That's a big point that many people get tripped up on. And as we're looking at these ranges of addresses, you might notice that there's a conspicuous absence. 127. Why is 127 not included as either Class A or Class B? Well, 127 is used for a loopback IP address. It's your local address. If you want to make sure the TCP/IP stack is working on your computer, you could ping 127.0.0.1. And if that ping is successful, then you know that your machine, your host, has successfully loaded the TCP/IP stack. Another question that might come from this discussion is, where does a company get their range of IP addresses to assign to their devices? Well, publicly routable IP addresses, and shortly we'll be distinguishing between public and private IP addresses, but publicly routable IP addresses, those addresses are managed by ICANN, I-C-A-N-N. That's the Internet Corporation for Assigned Names and Numbers. It's a nonprofit organization, and ICANN, they don't directly assign a block of numbers to your company or to your service provider, but instead it gives a block of numbers to an international registry. For example, in North America, we have ARIN, ARIN, the American Registry for Internet Numbers. Outside of North America, there is the Internet Assigned Numbers Authority, which is operated by ICANN. And by the way, in some of the literature, you might see a reference to INTERNIC. That's the Internet Network Information Center. That was the predecessor to ICANN, but it switched over to ICANN in September of 1998. And the big takeaways, again, from this video are that we have 5 classes of IP addresses when it comes to IPv4. Only 3 of those classes are going to be assigned to hosts, and those are classes A, B, and C. We can determine each of those classes have a default or a classful subnet mask. We've got 255.0.0.0 for class A, 255.255.0.0 for class B, and 255.255.255.0 for class C. And we can entirely determine the class of IPv4 address just by looking at the first octet. If we see an IP address of 10.1.2.3, doesn't matter what the subnet mask is, because we have a 10 in the first octet, and as we can see from the table on screen, that falls in the range of 1 through 126. That's all the information we need to know that it is a Class A address. In our next video, we want to take a look at some selected ranges of IP addresses that are used for private IP addressing, maybe within a corporation. One of the biggest challenges with IPv4 addresses is that we're running out of them. There simply are not enough IPv4 addresses to go around to everybody in the world that needs an IP address. IPv6 is going to be coming to the rescue. However, we still have a big IPv4 deployment out there, and what a lot of companies have done, they said, well, from my service provider, I know they're not going to be able to give me 500 or 5,000 IP addresses that I need for my internal use. So what I'll do instead is use a private range of IP addresses. I can route inside of my company using plenty of these private IP addresses, but this private IP address, it needs to be translated into a publicly routable IP address, and we can have several IP addresses translated into the same publicly routable IP address. Think about in your home, if you have a wireless router connected to your cable modem or connected to DSL, you might have a laptop, you might have a tablet, a smartphone, a desktop, all connected out to the internet at the same time, maybe a gaming console as well, but your service provider has only given you one publicly routable IP address. What's happening inside of that wireless router is something called network address translation, where we can translate between this unroutable pool of private IP addresses to one or more IP addresses that are publicly routable. And that's going to be a discussion for later on when we distinguish between network address translation and port address translation. For now, in this video, I just need you to understand that there are certain ranges of IP addresses that are for use inside our company or inside our home. They're private IP addresses. These are not going to be routable on the public internet. And we've got ranges of IP addresses for classes A, B, and C. Let's take a look at each one of these. Many people just gravitate towards the 10 dot address space because there are so many addresses available in the 10 dot address space. We've got 24 bits that we could use to assign to hosts. That's over 16 million IP addresses. So many people just use the 10 dot address space inside their company and then translate that into one or more publicly routable IP addresses. In the Class B address range, we've got 172.16.0.0 with a /16 mask. Many people use that. One that's really common on a lot of wireless routers out there, they'll want you to use a Class C private IP address. And there are plenty to pick from. We start with 192.168, and we can play with the rest of the bits to make up our own internal addresses, subnets, host addresses. And these addresses that we've talked about thus far, the 10 dot address space, the 172 address space. Oh, and by the way, in the 172 address space, notice the second octet. A lot of people miss this. The second octet does not have to be 16. It can go all the way through 31. So it's 172.16.0.0 all the way through 172.31. 192.255.255, and we talked about the 192.168 address space as well. Why did we skip over the 169.254.0.0/16 address space? Well, out of all of these private IP address ranges, that one, the 169.254.0.0/16 address space, it is not routable. Even inside your organization, it is not routable even by a router that you own. And generally, we do not want our host to have an IP address in this range. What this is a self-assigned address. A device on our network wanted an IP address, but we didn't manually assign one. It didn't dynamically learn one from an address server like a D8CP, a dynamic host configuration protocol server. So what did it do? It just self-assigned an address to itself so that it could speak IP. This is generally an indication that something has failed. This host needs attention. It needs an IP address that is routable. IP addresses in this range are known as IPv4 addresses. And the big takeaway from this video is that we have ranges of private IP addresses. IP addresses that are not going to be routable on the public internet. We could use those inside of our company and then translate those into a routable IP address that we get from our internet service provider. But be cautious of that one address, the 169.254.0.0/16 range. That range generally indicates a failure. That's a self-assigned address, and it's not routable even within your private network.